The bright line emission spectrum is generated when electrons move from higher to lower energy levels, which is what we can see here. And so the model that you want to use for this, remember, we have the Bohr model, and if we're looking at electrons here and they jump, when they fall back down, they emit energy as light. This is why we see light with different colors. Okay, so the next problem asks us, how many atoms are there in 35.3 grams of zinc? So the first thing he says is to divide the mass by the molar mass. So they give us that we have 35.3 grams of zinc. And so we're going to say we take 1 mole of zinc, and we're going to divide by 65.39 grams of zinc. All right, this right here, that's your molar mass, okay? So in the calculator, you should be putting 35.3 divided by 65.39. And that should give you 0.53, I think, 98. And this would be moles. Okay. And the reason that I went with, in this case, you'll notice that there are 4 significant figures here, is because we've got 3, and our end result has to have 3 significant figures, okay? And so you'll see written as this 3SF. So we're going to carry that to 4, and then at the end round, okay? So the next step says that I'm going to take this 0.5398, and I'm going to multiply it. So these are moles, sorry, let me write moles. And I'm going to multiply this by, for every 1 mole, we have, this is of zinc, right? We have 6.02 times 10 to the 23 atoms. Okay. And for that answer, you should get 3.25 times 10 to the 23, and your units here would be atoms. Now, when you put this into your calculator, this is what it should look like, but you should put into your calculator 0.5398 and then put times 6.02, and then you're going to hit the EXP button. Okay, 23, and then hit equals. And you'll get something like 249, but remember, since this is a 9, we're going to round up, which is how you get the 3.25 times 10 to the 23. All right, so for this next problem, they're going to ask us they want to know what is the wavelength. Okay, so that's what we're looking for. And they give us a wave, and they give us the frequency, so that is given. So that is our F. Okay. We know here this says c is the speed of light. This will always be given to you. This is 3.0 times 10 to the 8th. And so we're going to put this into our calculator, and we're going to say, well, it should look like this, 3.0, that's a 0, times 10 to the 8th, divided by 9.12, times 10 to the 14. Okay? And so the answer that you should get for this, all right, so your answer here should have been 3.29. So we get 3.29 times 10 to the negative 7. Okay, and this would be in meters. What else do I want to tell you on this one? Oh, again, when you are typing this into the calculator, any time you see this times 10, or here you've got times 10, remember instead we're writing EXP. well, not writing that, sorry, you're typing that into your calculator, EXP, okay? All right, so for this next problem here, it's asking what is the energy, okay? So again, we're going to use this equation here because it gives us energy. It gives us E. It's associated with a wavelength, so we have lambda. So remember, this is lambda of 225 nanometers. Now, the one thing you have to do with this 225 nanometers is you've got to convert this to meters. And the reason we have to do that is because, again, if we look up here, our speed of light is in meters. So since that is in meters, we have to convert our nanometers to meters. And the way we do that is we take our 225 and we multiply it by 1 times 10 to the negative ninth. So you get 225 times 10 to the negative ninth, okay? Right here. So basically what you notice is if you have 225 nanometers, then all you basically have to do is take this times 10 to the negative 9 and put it in behind there. So that's what you want to do each time. Now, to go back to our problem, so the first thing we want to do is we want to say, okay, well, they gave me wavelength, and so we're going to say we're going to take our 3.0 times 10 to the 8th divided by our wavelength here, okay, which is 225 times 10 to the negative ninth. And for that, we end up getting, we get 1.33, and it's repeating, so we're going to go 1.33 times 10 to the 15. So this is equals our F, okay? So now we're going to take our F, right, and we're going to plug that into our F here. So let me change colors here. We're going to use H. Now, H in this case, have we done an H yet? No. All right, so H is always going to equal, it's highlighted over here, 6.626 times 10 to the negative 34. It's a constant, just like pi, okay? And so we're going to take our H, so we're going to take our 6.626 times 10 to the negative 34, and we are going to multiply that by our 1.33 times 10 to the 15th. And this will give us our energy, which is, so this is going to equal 8.83 times 10 to the negative 19, and your units are joules. So that's how you solve that problem. And just remember that if it says it asks for energy and it gives you wavelength, we've got two equations that we have to use there, okay? All right, so now in this problem here, they're asking us for, in this case, they're asking what is the wavelength, okay, of a quantum of energy. In this case, the wavelength has to be in nanometers. So once we get our wavelength, we've got to convert it. So what's given to us is our energy. So this is our E. So we're going to look for frequency, because once we find F, right, which is here, we can find lambda, which, remember, this is our lambda here. All right, so the first part of this is we want to look for our energy. So this was 4.21 times 10 to the negative 19. And this is given to us in the problem. Okay, that's a 9. And we're going to divide this by 6.626 times 10 to the negative 34. That was in our previous problem. That's always going to be given to us. That's our H, right? That's a 3. All right, and so what do we get for that? All right, so for this we get 6.35 times 10 to the 14, and these are in hertz. Okay, so this is our F, and so now all we need to do is we need to put this back into the equation over here. So we're going to say C, which we know is the speed of light. So 3.0 times 10 to the 8th divided by 6.35 times 10 to the 14, and we get, all right, so this equals 4.72, yeah, 4. Give me a second. All right, 4.72 times 10 to the negative 7. Remember, just like we talked about in class, when you see this here, this to the negative 7, remember we're going to move the decimal point 2 places, which would give us 472 times 10 to the negative 9. So once we see this times 10 to the negative 9, we know that equals nanometers. And so your answer, move right down here, would just be 472 nanometers. Okay? All right, so let's move on to the next problem here. So the next problem here is, what is the average atomic mass? All right, so the first thing we do, you guys, we've done these problems repeatedly, right? We're going to divide this by 100, divide this one by 100, and divide this by 100. Okay, so what you end up with is 0.923, and we're going to multiply this by the 22.81, which is my mass here. Then I'm going to take the 0.0540 times 23.23, and I'm going to take 0.0230 times 24.11. And so for each of these, what I get, all right, so this first one I get 21.05, what's the next one, 4. For this next one here, I get 1.2544, and for the next one, I get 0.5545. So the next step here is we're going to add all of these numbers together, and what you end up with is, you end up with 22.8, doesn't want to draw, sorry, 862. And remember, what we want to do is, since our mass is given to us in 4 significant figures, we want to have the answer in 4 significant figures. So your answer here would have been 22.86. That would have been your answer on that one. All right, and the final problem is here. It says, what is the electron configuration for S? So again, we're going to use our periodic table. And when we go to our periodic table, we know that S has 32 electrons, okay? So the first one we go through is we go through 1s, okay? Then we go, and there's 2 of them. Then we go through 2s, there's 2 electrons. We go 2p, which gives us 6. Then we're going to go to 3s, which gives us 2, and then we're going to go to 3p, 4. I'm sorry, it's not 32. It's 16 electrons. Sorry. So what you're going to see here is that we have a total of 2 plus 2 is 4, plus 6 is 10, plus another 2 is going to give us 12, plus another 4 is 16. So we have a total of 16 electrons. Okay, and so for our last problem here, we have our noble gas configuration for bromine. And so the first thing I want to do is just write the regular electron configuration. Okay, and so again, we're going to start the same way. So with bromine, we're going to say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and we're going to end with 4p5. So the key things here to remember, when you get to your D's, it's down a level, okay? And the other thing we want to look at is, what was the noble gas that we got to before we hit bromine? And so if we look right here, this is the last completed level. We'll be here at level 3, and this is argon. So for the noble gas configuration, we would write argon. So we write this right here. Instead of writing all of that, we can write argon. So we have argon, and then what comes after argon is 4s2, 3d10, and 4p5. I'll have another little video that I'm going to post if you guys need a little bit more help with electron configuration. So you want to go to Edmodo, and the code for that is G4RPES. Okay, and that's where you're going to find the next problem. So you have 8 problems that you would need to turn in with the work that you turned in from this. So there'll be 8 more problems that you need to complete in order to get your credit for or your points back on this test. So complete all of these, and then go to these problems here, and then go to Edmodo and complete the next 8 problems.